Hello, this is question 4 of our exam. So, we are having to solve the integral of sine to the square root x dx. So, first things first, I find it really troublesome to work with this what's inside. So what I'm gonna do is do U-substitution. I'm going to let u equal the square root of x. I'm going to derive both sides. And it's du. This is x to the 1/2 power. So I'm going to bring that down and subtract it by 1. 1/2 comes down. X to the negative 1/2. And then that would just be brought down to the bottom. Oh, dx. Don't forget your dx's. 1/2 square root of x dx. Now, when you do use sub and you still end up with x, that is usually a problem, and that means that you performed it wrong. However, what you can do here is, because your u equals the square root of x, you can just plug that u in right here. So you would get du equals 1/2u dx. So now that you have your variable back in terms of u, you're all good. You just need to move things over. You would multiply 2u on both sides. 2u du equals dx. Now that this is good, you can substitute it in. And we don't have any bounds, so we don't have to change that. So this then becomes the integral of sine u, I'm going to put parentheses around that, du, and then we're multiplying by 2u. What I do instantly is I move out any coefficients if I can. So I do not want to worry about them, and they will sometimes complicate things. So the 2 gets pulled out, that's fine. I'm also going to move the u to the front, just to make it look nice. Sine u du. So now that we've substituted things in for u, we have two things being multiplied. And to solve that, we use this formula that I will write up here. The integral of two things being multiplied, which I will use, pardon me, in terms of u and v. I'll use the formula. So whenever two things are being multiplied, they equal the multiplication of those two things minus the integral of, pardon me, this is the formula. I only wrote in green to tell apart the u and the v. So we have to write down which one is our u and which one is our v. And I'll do that on the bottom here. I'm going to let my u value for this equation, well, I'm going to let our u equal our u right there. And we have to derive it. So du equals, well, this will just be 1. I'm going to put the du there as well. And then our dv me write this again right there, is our sine of u, and then we have to integrate that into v. So the integral of sine u is negative cosine of u. So now that we have our u, du, our dv, and our v, we can plug everything back into this formula right here. And I will write it on the bottom. So we have u times our v, which is negative cosine u. I'm going to pull out the minus sign, put it right there. So we got u cosine of u minus the integral of v is right here again, negative cosine u du. This is our du. The 1 we don't have to write. So this we have seen plenty of times before, and this is not being multiplied by anything that we can't work with. So this, we can solve it. I will write it here again. Going to pull out this minus and just put it right there, making this a plus. So the integral of cosine of u is sine of u. Now, even though this looks satisfying, we have one last final step. What I am going to do is I'm going to plug back in what we subbed in for u, which is the square root of x. So the big and final answer is minus square root of x times the cosine of x, cosine of square root of x, my bad, plus, these are being multiplied, sine square root of x. This is our answer.